on ktalk.co.za,
on the app,
on DSTV channel 885,
and across the city on 567 AM.
Join the conversation.
This is Cape Talk.
This is Cape Talk.
Coming up 28 minutes to 10 o'clock, I'm Zane Johnson in for Lester Kivett. We are with the Naked Scientist, Chris Smith, this morning. Good morning, Chris, and welcome to the show once again.
Morning, Zane.
How are you, sir?
Yeah, I'm good. Another interesting week. We've seen this week the emergence of another variant of coronavirus, of course. We've got Colombia's Mu variant. We've seen the emergence of C12 in South Africa. Scientists keeping an eye on that, and the WHO over in Germany have now physically opened their pandemic surveillance hub. So we've got something for them to look at in their surveillance hub and process what these variants are doing and look for pandemics afresh all over the world.
And if you want to follow The Naked Scientist, it's at www.thenakedscientist.com. First question up this morning, Dr. Chris. There is only one perfect planet for human life in the solar system. We have nearly messed it up. Now, Musk plans to mess with Mars. What do you think of that? And it comes from Perry and Rondebosch.
I think that there's a number of ways of looking at this. One is that inevitably, when we do invest hard in problems that are hard to solve, there are spin-offs. The reason we all have Wi-Fi is because scientists wanted to study the universe at large, and radio astronomy led to the kinds of protocols that have led to home Wi-Fi. There are examples of materials science which, in trying to conquer space, have led to better hip replacements here on Earth, including biros that can apparently write upside down, but I'm not sure if that's true or not. But we have other spin-offs like Velcro and like Teflon. So when we invest in hard problems, we do inevitably solve problems that are very relevant to us down here on Earth as well. So I'm always fond of trying to solve hard problems, and hard problems often involve solving the problems of space, because it is an area that's been under-invested in and underexplored because it's hard to get to. So in that respect, I think it's really good that people are putting hard money into hard problems that will inevitably have spin-offs. Whether or not we're doing this responsibly, that's a different debate. And some people are saying, well, look, we've got lots of problems here on Earth, which we should try and tackle those first before we, as you say, potentially pollute other planets. So I'm sympathetic to that argument. Whatever we do, we have to do it incredibly responsibly. We live in a pristine solar system. Yes, the Earth is now a mess, and the orbit around the Earth is now a mess. Let's not make the same mistakes twice. We are already seeing people making forays back towards the moon. That's scheduled within the coming decade. Mars is also on the agenda, and so I do think that whatever we do, we must make sure that we don't mess it up. And I hope that the fact that it's hard to get to these places limits the opportunity for mass movement and mass messing up. But I would like to see that this is done responsibly. But I'm not against the development and investment in the technology, because I think there will be really tangible benefits for everybody when people spend hard and spend big like this.
Chatting to the Naked Scientist this morning, Dr. Chris Smith. Gisela is on the line from Durbanville, and she's got a question relating to antimatter. Good morning to you, Gisela, and welcome to Cape Talk.
Yes, hi, good morning. Last week, you were talking about antimatter. And I assume that we, as humans, are also matter, so we should also have antimatter. And you said that if the two meet, there would be an explosion. How would this relate to human beings?
That's right. The universe is made up, when we look out into space and we look at what's around us, we see that the material that we're all made of is made of matter. Matter has a mirror image, which is antimatter, which behaves in physical and chemical terms in an identical way, except it is the mirror image. And if the two meet, then they cancel each other out. But because you can't remove the energy from the equation, when they obliterate or annihilate each other, they release energy. But we do occasionally end up with antimatter in our bodies. And this is because we can make antimatter. Scientists know that this stuff can exist because we can make it, or we can make things that when they decay radioactively can produce antimatter. And when you do this in the human body, you can produce signals that you can use for scans. So when we do positron emission tomography, for example, we are using that very interaction of matter and antimatter as a way of seeing what's inside the body, because we can detect the signals that come out when this happens. So therefore, the human body is matter, but it can have some antimatter in it for a short period of time. So we can make antimatter, but where it's all gone in the universe, naturally, we don't know. And the big question is, well, if the universe was produced in the way we think it was produced, the theories suggest there should be equal amounts of matter and antimatter. So where's all the antimatter gone? And that's a question at the moment we're grappling with and we can't solve.
And I hope that answers Gisela's question from Durbanville. A doctor on the line with us this morning is Audrey from Rondebosch. And Audrey suffers and wants to ask a question about something that I think I suffer from, which is cluster headaches. Good morning, Audrey.
Good morning to you. So what I really want to know is what causes these cluster headaches, which I believe are different to the ordinary migraine headaches, and can they be avoided? And is there any medication, or what is the best medication to deal with them?
As the name suggests, this is pain in the head. But they're not like your classic tension headache, which usually happens when you've had a long, hard day, when you haven't drunk enough, or you've been stressed for a prolonged period of time. Also, when you have certain illnesses like viral infections, you get a generalised headache. That's relatively mild compared to the phenomenon, which is a real medical entity called cluster headaches. These are headaches which are excruciatingly painful. They come on very abruptly. They usually cause pain around an eye. People may say that they get a red or watery eye associated with it. They might get a droopy eyelid that goes with it. Sometimes there's sweating that comes with it, and you might notice that you have a blocked or a runny nostril that goes with it. They're called cluster headaches because they do come in clusters between 1 and 8 times a day is the classic numbers that we're told. And they last for minutes in some cases through to hours in other cases. And they can never happen before, suddenly start to happen, and then suddenly stop happening. We don't know exactly why they happen, but people who are smokers seem to be at higher risk of cluster headache. We don't know whether this is because of chemicals in the cigarettes that activate certain parts of the nervous system and make this happen. They seem to be linked to altered or abnormal activity in the part of the brain called the hypothalamus. Now, the hypothalamus controls your autonomic or automatic nervous system. It's the part of the nervous system that does all the jobs that happen in your subconscious, which you don't normally have to worry about. So perhaps it is that something, an environmental trigger or a physical trigger inside the body or a chemical trigger, activates this part of the brain, which then activates certain arms of the nervous system you have no control over, and that causes these symptoms to happen. But, various other innocuous things like certain smells, even perfume, can trigger this off in some people. It's otherwise relatively poorly defined. And they can happen for some people over just a day and then go away and that's it, or they can happen for weeks. Some people have attacks of them that can go on for weeks at a time. So if this happens to you, do get it investigated, because of course there may be other things that are causing these symptoms that can be treated that need investigating. So don't ignore these symptoms, but try simple remedies first. If you do get this, simple painkillers like paracetamol, for example. If it doesn't settle, then you should go and get it investigated to make sure we're not missing something else. And then if that still does not work, then the people can go and see specialists who have other things they can do to try to help people who've got the problem if it keeps recurring.
Chatting this morning to the Naked Scientist, Dr. Chris Smith, and your questions and your calls on 0214460567 or your voice notes on the WhatsApp line on 0725671567. Laura is on the line from Goodwood this morning. Your question for the doctor this morning, Laura, and welcome to Cape Talk.
I heard about mold slime, and it said it has some intelligence and memory. Is that so?
What's the stuff again, Laura?
Mold slime, MOLD, and then slime. It's supposed to be an amoeba.
I must admit I don't know about that story, but if you can send me a reference to what you're referring to, I will take that away as some homework and come back with information on it next time.
I heard about it on DSTV, and then I also looked it up on Google.
Right, okay, well, I'll take a look for you and see if I can find out what it is you're referring to. Talking of homework, I did receive some feedback in response to last week's programme, which was brilliant, by the way, and thanks very much to the kids who took part. Absolutely superb questions, very, very hard. One of the things we talked about was a circle, a perfect circle, and pi, and I said that the correct value for pi was 22/7. That was naughty. I should have said an approximation for pi is 22 divided by 7. That is a simple, convenient and quick way to define pi. So I'm sorry about getting pi as 22/7. I should have said it's actually 3.14159, etc.
I taught maths and it was always 22/7, and then eventually it became 3.149 as you indicated there. Chatting this morning to Dr. Chris Smith, and if you'd like to give us a call on 0214460567, Amy Ray takes your calls, and Johannes will be playing your voice notes on 0725671567 if you'd love to join the conversation. Farida out in Bellville, a very good morning to you and welcome to the show. Your question for Dr. Chris.
Hello, Dr. Chris. I want to know, I had an avocado that never got soft, so I decided to try putting it in the microwave, and the pit separated from the avocado. I don't know what caused it, if I did the wrong thing.
Probably was the wrong thing to do unless you like cooked avocado. There's a couple of things to consider here. Number one, anything put in the microwave which you don't know what the outcome would be very, very careful, because you can get hot spots in the thing and it can explode all over you, especially fruits and things with skins on. They can get very hot. Eggs the same, so be very careful. There's also a very big, as you say, pip or seed, the central nut in the centre of an avocado, the stone, and that could get very, very hot and potentially burst open. So be careful, because you might create a bomb in your microwave. I don't know why it didn't soften. Most avocados, the problem is the opposite one, that they soften too quickly. But your one may have been just underripe or something like that. But I certainly wouldn't have put it in the microwave. The reason things soften as they age is because various chemical processes kick in with the ripening process, and when something ripens, it releases into its flesh enzymes, and those enzymes break down various things within the fruit and change the characteristic, because they break down fibrous tissue and turn the fibrous tissue into juices, and that's the softening process. If that's not happening, heating it up might not help and probably won't taste very nice, because you're not accelerating the ripening process. You're basically just softening the fibrous tissue by driving water into it, a bit like spaghetti goes soft when you cook it. So I'm not sure that I would resort to that again. I'd probably just squeeze your avocado at the shop a bit better, find one that you feel is on the way to becoming soft, and then hopefully it'll be delicious in 3 days, and eat it the normal way.
That was Frida's question out in Bellville, the avocado that didn't get soft. Francois is out in Hout Bay, and he's got a question for us this morning. Good morning, Francois, and welcome to Cape Talk. Your question for Dr. Chris Smith, please.
Hi, Chris. Just a quick, before I ask my question, I also suffer from cluster headaches occasionally. Something that helps for me is taking a very, very hot shower while I'm having an attack. And somebody also told me to do the medicine for arthritis is called Arthrexin, which is also something that I drink, and it also helps. Just a tip on that.
Well, that's very helpful to hear. There's another one which I learned, which is that, and I didn't know this, is that breathing oxygen, people are given oxygen in a face mask, and 15 to 20 minutes of oxygen apparently makes it go away. And also some anti-migraine treatments, sumatriptan and other triptan drugs, which have effects on blood vessels and are used very successfully as preventatives against migraine, can help some people. Normal remedies like paracetamol don't act quickly enough, but because some people may diagnose themselves with cluster headaches when in fact they don't have a cluster headache, taking normal remedies like paracetamol as a first step, if you're able to take paracetamol, of course, is always a good idea. But the whole thing about oxygen therapy is that it probably plugs into the same mechanism we were just talking about, which is it's going to affect the behaviour of the automatic part of the nervous system, which is almost certainly bound up in how this condition manifests itself. And that's probably how that works, although it remains ill-defined.
Okay. My question was, in the beginning of the year, I sort of started noticing my eyesight going backwards. I had to take my phone further and further away from my face to read it. Now, I picked up COVID 2 weeks ago, and I've started drinking all kinds of vitamins and supplements and all kinds of things. And strangely, my eyesight has sort of started returning to normal again. I noticed that one morning when I was lying in bed. Obviously, you're lying in bed watching whatever Netflix while you're being sick. Is there a certain vitamin that could cause this, or a supplement that I might not have taken in the past that now with COVID, like zinc or something like that could actually bring back your eyesight to its normal state?
The reason that we become more long-sighted as we get older is because the lens, which sits behind the front part of the eye called the cornea, becomes stiffer with age. And the lens does about 15% of the job of focusing. And we achieve a clear focus by moving the lens and also changing the size of the pupil. Because we've had on this program before discussions about pinhole cameras. If you look through a very tiny pinhole in a piece of paper, or look through a tiny aperture, everything in the distance that was perhaps a bit blurry becomes very sharply focused, because this has the effect, the pinhole, of minimising the light that comes through, so that individual rays of light come to the pinhole, go through the pinhole, and then fall on the retina and illuminate only a tiny patch of the retina. So you get a very clearly focused, but because there's less light coming in, a dim representation of what you're looking at. Now, as the lens stiffens in the human eye with age, because you lose that ability to add additional tweaking, you're much more reliant on using pupil size and pupil diameter to achieve a pinhole effect, to keep things focused. And this is why, as we get older, we tend to prefer more brightly lit environments, because if you can brightly illuminate the environment, you can make the pupil correspondingly a lot smaller, and that works like a pinhole and now enables you to achieve focus. So in your case, a few things could be going on. One is that you could actually be looking at nice bright things, not less bright things, and that could be helping you with your pupil size. Secondly, if you have been taking good care of yourself because you've not been feeling well, perhaps what you've been doing is drinking more. And what people often say is that if they're better hydrated, the lens tissue, the proteins in the lens, the crystallins that do the focusing in the lens, are more optimally arranged and hydrated, so they can do their focusing job a bit better. So it might well be that because you're feeling better now, but because you are looking after yourself better, you are better hydrated, and it's that better hydration status together with perhaps being in a more brightly lit environment that's helping to compensate for, unfortunately, the irreversible effects of aging, which is a stiffening of the lens and a move towards the condition presbyopia, which is where we're less good at focusing over big ranges of distance, both close up but also into the very far distance.
Dr. Yeze, question on the WhatsApp line this morning.
Hi, Dr. Chris. I was wondering, what is an atomic clock and how does it work? Thank you very much. Bye.
Chris?
The atomic clocks work by resonance. So what they do is to use usually cesium atoms. They are stimulated by microwaves, I think, in order to make them resonate. And because they have an intrinsic frequency at which they behave in this way, it's predictable. And so what you can do is to measure the movement of these atoms in response to this stimulation, and they will oscillate at a very specific rate, or they will move at a very specific rate, and that enables you to have a very precise timekeeping. I mean, it's precise down to tens of decimal places, and so it is basically using the resonance of atoms in order to keep time. If you think about a pendulum swinging, it's an atomic-sized pendulum that's swinging in a clock, which you can measure, and that enables you to therefore keep time very precisely.
Dr. Chris Smith chatting to us this morning. Here's another voice note coming in.
Hi, good morning, Chris. It's John here from Meadowridge. Many years ago, I learnt about the second law of thermodynamics and entropy, and I understood it at the time, or I thought I did. And more recently, I was wondering that as we know, everything on Earth tends towards equilibrium, be it air pressures or water levels. And I was just wondering whether this phenomenon of equilibrium actually is a result of entropy. If you could just perhaps clarify that. Thanks.
I think entropy was one of the big breakthrough moments for me at school, learning about this and understanding the concept. And it's a science that's maybe 150 plus years old now. But the idea of entropy is that everything is moving from a state of order to a state of more disorder. And the idea is that the more disordered things are, the more random they are, the more likely that process is to happen that leads to that. You can see this happening in your home, because if you go in your child's bedroom and it's nice and tidy, by the time they come home after school and then go to bed, everything has gone from a state of order to a state of disorder. And it's all about probability. How many ways are there to organise things in a highly organised, ordered way versus how many ways are there to organise things in a highly disorganised way? Well, there are many more opportunities and ways to arrange things in a disorganised way. So therefore, nature will naturally move from a state of order to a state of spread out disorder. And because you are achieving that big increase in entropy, that big increase in disorder, you get energy flowing in the same way. And so you can look at the way in which things happen around you, or why things happen, or the processes that tend to occur. And as long as the entropy, the overall increase in disorder, is greater, then that process will happen. A good example of this, if I take a piece of metal and I drop it into acid, the metal is a highly organised thing with all the atoms lined up in one particular way. If I drop that into some acid, it will react with the acid and it will produce some hydrogen gas, and the particles of metal will produce some salts in solution in the liquid. Well, that gas is going to take up lots of space, and there's loads of ways to arrange all the atoms and molecules of gas in space. So therefore, that's a very big increase in entropy from one compact piece of metal and a little bit of liquid into a gas that's spread out all over the place with enormous numbers of ways of arranging the particles. Huge increase in entropy. So that's why that reaction happens. And if you think about when you look at a situation and you ask, will there be an overall increase in entropy here? Will the system become more disordered if this happens? And if the answer is yes, then it will happen. And that's how the universe works. And I think that was an amazing insight for the scientists who first came up with this, including Boltzmann, who was one of the scientists who had these sorts of insights over 100 years ago.
I'm actually gonna follow up and have a look at entropy and exactly what it is, because I bought my daughter a sort of a badge for her room that says my room was clean, you just missed it. So maybe that's one of the things. Another voice note coming off the line on 0725671567 for you, Chris.
Good morning, it's AB here. I would like to ask Dr. Chris why a magnet loses its magnetism when it is heated up. Thank you very much.
Doctor?
Magnetic materials, usually iron-rich materials, are magnetic because inside the magnet is a system of entities called dipoles. Now, the terminology is that the dipoles, or these atoms inside the magnet, have a function called spin. And so if you think about this as literally something spinning, when you have a piece of metal that's not magnetic, all of the particles are randomly organised, and so the spins are all randomly organised. But when you magnetise a piece of metal, you line up all of those quantum spins, so the dipoles are all pointing in the same direction, and this leads to a field. Because if they were all randomly organised, all of the effects would cancel each other out and there's no net magnetic field. But if you line them all up inside the magnet, so all the spins are going in the same direction, they all add together and you get a magnetic field. Now, in order to get them aligned, what you do is to warm the material up, place it in the presence of a magnetic field or an electromagnet, and then all of the spins, all the quantum states line up, and then you cool it, locking them into position, and you get your permanent magnet. But if you heat the material up again to the point at which those spin states can become mobile again, they will flick away from a state of highly ordered arrangement. We were just talking about entropy. That's a highly organised system where all of the dipoles are lined up. They don't want, in inverted commas, to be in that configuration because that's highly ordered, and there are many more ways to have them in a disordered way, second law of thermodynamics, so they flick back to be in all kinds of random orientations, and you no longer have a magnetic field. So that's why heating up a permanent magnet to the point at which all those particles become mobile again loses magnetization. Similarly, if you have a permanent magnet and you keep dropping it over time, by dropping a magnet, you also disturb those orientations of those spin states and slowly erode down the field.
Doctor, a very interesting question, but we've got about a minute before the news. Good morning, Zen and Dr. Chris. I would like to know why people are still being asked to sanitize when it's been proved that it's almost impossible to catch COVID from surfaces. This bothers me a lot, and we would appreciate your views on it. Kind thanks, and it comes from Kenton.
Kenton, to a degree, the coronavirus does spread through personal contact and touching surfaces, but that's a trivial part of the equation. The vast majority of transmissions are respiratory infections, or respiratory spread through particles in the air. But it's good practice to have good hand hygiene anyway, because some viruses, including some respiratory viruses, do linger on surfaces for very long periods of time, and other gut bugs like the norovirus that causes diarrhea and vomiting also lurks on surfaces for very long periods of time. So having good hand hygiene and an awareness of the ability of surfaces to transmit infection is a really good idea, because it will help to protect you not just against the new coronavirus, but it will help to protect you and your family against a whole raft of infections.
And that brings us to 10 o'clock. Dr. Chris Smith chatting to us as Naked Scientist. If you'd love to follow him, it's on thenakedscientist.com.
On capetalk.co.za,
On the app
on DSTV channel 885.
and across the city on 567 AM.
Join the conversation.
This is Cape Talk.